Hi, good evening. This is Yong Kei Soon back again on Milestone 2 submission. Today we're going to look at data management on Milestone 2. So it's going to be some quite interesting. To start with, this is our database schema. At the center of this database schema is our company fact table, which contains the counter code name, and also the name of the company and which sector they are in. And this is linked to its stock price, which is grabbed daily on the daily prices movement. The yellow columns indicates it's a engineered fields. In this case, we're going to generate moving average 5 days, 10 days, 20 days, and 30 days over time period. We engineer those fields. Other than this, the company also linked to business news, which we pull daily as well from the news website. And we also found a very interesting forum post. We will talk about the stocks, and we're going to check how active the counters has been discussed. Right. At the center of this is also a calendar table. Calendar table is basically a list of dates that we are actively pulling data. This is linked to the date is linked to some other tables, and like the major indexes, where we pull data from other stock exchanges, and commodities prices. In particular, we're interested in oil and gold movement. Major forex, specifically, we want to track US dollar to Malaysian ringgit conversion. And daily, we also track what people has been discussing on each of the stock on Twitter, right? So this basically form our database schema. We had evaluated two database storage systems. We've chosen Google BigQuery for some good reasons over Hadoop, right? Firstly, it's serverless because it's based on Google Cloud, so there's really no initial setup tasks need to be done. And we know these systems can scale. In production, they have reported that it can be scaled up to petabytes of storage. It supports very well database tables. Compared to Hadoop, of course, this is not a HDFS systems, so it doesn't store non-structured data, right? But it has very good database support. And interaction with Google BigQuery can be done real time, or near real time. Okay. Only downside is Google BigQuery is basically a very structured column-based, row and column-based storage, whereas Hadoop can store any data. So there's main difference. But in our use case, we only require storage on the row and columns. And it's really easy to set up. All we need to do is just define the schemas and we are ready to go. And one key criteria is Google BigQuery are able to integrate to many other tools, which I will show later, such as R, Python, Tableau, even reported in other tools as well. In our case, we actively using Python for the API and Tableau for the visualization. Right. And it has a very well standard SQL-like syntax support. All the queries is done through SQL-like syntax. And search speed is fast. And bottom line, we choose Google BigQuery is because it's big, it's fast, it's cheap, and it has a lot of computing power. It's a database, right? So exactly how big is Google BigQuery, right? So it's reported Google BigQuery can support petabytes of storage starting from day 0, right? So because it's subscription based, of course, if in day 1 if you require petabytes of data, you need to contact Google, right? So they make sure they provision for you. How fast is BigQuery? In the published report, Google BigQuery can process 4 terabytes of data within 30 seconds with the processing of 3 wildcards regular expression query. So that is really fast. And obviously, one important consideration is cost. Good thing is Google is giving away $300 free access to any services within Google platform for a period of a year, right? And it's really not expensive. The first terabyte of active data is basically only $20 per month, and depends on how much data you query. First terabyte of query is basically free, right? So for entire projects, we don't expect to pay anything. Okay, so this is our data pipelines. As you can see from top here, all the various sources from the internet will be pulled into Google BigQuery through our scheduler. So we written virtual machines and Python scripts to extract the data, and we will transform in a way to clean up some data, conversions, and put in regular expressions to extract those important and necessary informations. Then only we load it to Google BigQuery, right? Basically a table. And from within Google BigQuery, we do another level of transformation to make sure we remove all the redundancies, and so that it can be presented nicely to our modeling tools and our visualization tools. In our case, we are using Tableau for our visualization. So Tableau has a very nice connector to Google BigQuery. It can extract and automatically from Google BigQuery, then we can do a visualization from there. We expect in the future we will be able to pull the data into our Python machine learning models to do our modeling, right? Using the same concept. Now let's dive into some of the things I'm going to show you, how Google BigQuery looks like, how we pull data into Tableau, and we also demonstrate how we can put some data into Hadoop for our future consideration. Maybe we want to try out Hadoop data warehousing. Okay, let's jump into the website and look at Google BigQuery. Yeah, I already opened it up. So this is how Google BigQuery looks like. These are all the tables that we pull in. For example, business news. You look at some sample raw data. This is what we get, including Chinese character as well. And all this will be cleaned up. First level clean up to remove any redundancies, especially with every day. If sometimes we do testings, we pull multiple copies of the same data. So we create the SQL to clean up the data, right? So basically, every table has got a relevant view created to remove the redundant data. This is the view SQL statements looks like, right? To run it, we simply hit run, right? Simply hit run, and then data will be presented. Okay, there are ways. This data can also be saved to the local PC, to CSV if somebody need it. Right. Okay, then let's look at Tableau, right? Tableau also offer a cloud service. I basically had uploaded our Tableau workbook into the cloud, right? This is how it looks like from the cloud. As you can see, since 25th February, we have been actively pulling data. Okay, we've been actively pulling data, especially stock price among the first data source we pull in, right? So every day we have this 948 records being pulled on a daily basis. Some data sources we started to capture late, some are just started recently. So in overall, I think we are good. Since yesterday, all data sources already start to come in, right? So really nice Tableau, right? Lastly, let's look at Hadoop, right? I had also successfully run Hadoop, and to show that it's running, this is how it looks like, right? And Hadoop, there's one node running, right? So let's go to our Hadoop console. Alright, so to look at what files are already put inside it is just this one. I created a directory within the Hadoop file systems. So far, I have one file's already been loaded. Oops, yeah. Oops, I should be listing it instead of creating the directory. Let's see. Yeah, so this is to show that the CSV file has been loaded from Google BigQuery to Hadoop. So thank you for watching. Hopefully next submission will be more interesting. Thank you.